Hi, welcome to my 6th class mathematics class, semester 2, mensuration. Up to the previous video, we have discussed about the perimeters of different regular shapes. Now come to the area of the plane shapes. See, observe all these figures. These are closed figures. They occupy certain space on the board. But can you tell which figure occupies larger space, more space? But we can't tell just looking at them. So if there is a large difference, we can tell this is a spacious, occupying greater area, and this is occupying lesser area. But these are approximately equal, occupying equal area, so we can't tell by just looking at them. So we have to place them on a grid paper or graph paper, on which square centimeters or square millimeters or square inches, part of the inches are drawn. So we will see that graph paper also. The space occupied by a closed figure is called area. The space occupied by a closed figure. All these figures are occupying certain area. That area we can't measure just by seeing the figure. Now we will place them on a graph sheet or graded paper and see how the area of different figures are measured. See, this is a grid paper. Let us, the grids are centimeter into centimeter, and there is a closed figure on it. By counting the square centimeters, we can say that the area of this closed figure is sum of the square centimeters, sum of the small squares. But here all the squares are not full squares, but here a part of the squares, this occupied only a part of the squares. Here the square is less than half. Here is it exactly half. Here it is less than half. Here it is greater than. So we can't estimate it as it is. So we will take some conventions. That is, if the object occupies a full square, we will take as a full square centimeter. If it occupies half square centimeter, we will take it half square, we will take it half square centimeter. If it occupies full square, we will take it as 1 full square centimeter. If it occupies less than half square centimeter, we will neglect. We don't take it. We take it as 0. If it occupies greater than half square centimeter, we take it as 1 square centimeter. So greater than half square centimeter is taken as 1 square centimeter. Less than half square centimeter is taken as 0, or it is neglected. Exactly half square centimeter is taken as half square centimeter itself, and the 1 square centimeter is taken as 1 square centimeter. Thus, by counting first the total squares, full squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17. I will again count. This is also there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So full squares are 17. Therefore, 17 square centimeters plus half squares. This is a full squares. Number of full squares. Number of half squares occupied by this enclosing figure, closed figure is half squares exactly. This is exactly half, and this is also taken as half, and this is half, this is half. So that's all. How many halves are there? 1, 2, 3, 4. 4 half squares are there. 4 half squares. 4 half squares. Half square centimeters are there. And next, we will count greater than half square centimeters. Number of greater than half square centimeters. This is greater than half. This is also greater than half. This is greater than half. That's all. There are 1, 2, 3, 4. 4 squares, half, more than half squares were there. So 4. So greater than half squares are 4. They are taken as 4 full square centimeters. Now less than half square centimeters. This is less than half, or this is less than half, this is less than half. All these are how many, whatever number. Suppose there are 6, we will neglect them. We don't take them. So counting and adding all this, 17 square centimeters plus 4 half square centimeters. 4 halves are 2. So 19 square centimeters plus 4. Altogether 23 square centimeters. The area of this figure is estimated as 23 square centimeters by keeping it on a grid paper. See here, the enclosed figure is formed by straight lines. Therefore, it is very easy to count. So we will. Therefore, there are only full squares and half squares only. Just count full squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 square centimeters. Full square centimeters are there. Therefore, 10 square centimeters plus and half only, half square centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 half, 12 half square centimeters. Half square centimeters. 12 halves are 6 square centimeters. Therefore, total 10 plus 6 is equal to 10 plus 6, 16 square centimeters. 16 square centimeters. Therefore, it is an exact value because there are only, the figure is made up of straight lines and there are only full squares and half squares. Therefore, there is no neglecting part or there is no extra taking part. Therefore, the exact area of this figure is 16 square centimeters. Thus, we can estimate the area of some closed figures. we will tabulate the results in this table like this. Covered area, full squares, half filled squares, more than half filled squares, as the half filled squares. So here we will count full squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 fully filled squares, 14. So area of estimated 14 square centimeters. 14 square centimeters. Now half filled squares. Half. This is 1/2. Exact half is only one. Only one exact half square. 1. Therefore half square centimeter. Half square centimeter. Next, more than half. 1 more than half. 2, 3, 4, 5, 6, 7, 8. 8 more than half squares were there. 8. Therefore more than half is taken as 1. Therefore 1. 8 more than half squares is equal to 8 square centimeters. Next, less than half filled squares. They are neglected. Whatever 1, 2, 3, 4, 5, 6, 7, 8. 8 squares were less than half filled, but they are neglected. Their area is taken as 0. Therefore, total area is 14 plus 8, 22 and a half. 22 and a half square centimeters. Total area of this figure estimated is 22 and a half, or we can write it as 22.5 square centimeter. 22.5 square centimeters. The area estimated by keeping it in a grid paper or a graph paper. Thus, the area of different figures are estimated in this method. In regular shapes, we can estimate or we can calculate the area of regular plane figures by using certain formulas that we will see in the next video.